In this lesson, we are going to deal with thermochemistry, which is the study of heat flows associated with chemical reactions. Now, a chemical reaction is generally accompanied by a temperature change. Pretty much when you do a chemical reaction, there's going to be a temperature change involved, even if the reactants and the surroundings are initially at the same temperature. So, we can say then that the temperature change is not due to heat flow. Why? Heat flow, by definition, is something that goes from something hot to something cold, right? But when you mix your reactants are at the same temperature. It's at the same temperature of the surroundings. You're mixing two things that are at the same temperature. The surroundings are at the same temperature. Why does the temperature change? So that temperature change cannot be due to heat flow. So what's happening there? Well, what happens is during a chemical reaction, you're going to have rearrangement of atoms, okay? And that leads to a change in potential energy. Now, if you imagine that system as isolated, okay, for the moment, at the instant the reaction occurred, let's say you have a fast reaction, then when the potential energy increases, then that means the kinetic energy of the atoms in the resulting products would be lower than they were before. So an increase in potential energy means a decrease in kinetic energy. Remember, potential energy plus kinetic energy must be a constant for an isolated system. So what does an increased temperature mean? An increased temperature actually means that the kinetic energy has actually increased, and that means the potential energy due to the rearrangement of the atoms has decreased. Okay? And so as a result of that, a consequence of that is that heat will now flow into the reaction, out of the product mixture. As a result of the reaction, the atoms are now, we should say, hotter than before. And so now it's going to be hotter than the surroundings. Heat's going to flow out because it's now going to be hotter than the surroundings. So you have what we would call an exothermic reaction. Similarly, if we have a decrease in temperature as a result of the reaction, so a reaction happened and the temperature went down, that means the kinetic energy of the products are lower than what they were when they were reactants. Okay, the atoms in the products will now have lower kinetic energy than they did when they were reactants. So that means there must have been an increase in potential energy. So a decreased temperature means an increase in potential energy of the atoms when they rearrange from reactants to products. And so that led to a lower kinetic energy. And lower kinetic energy, which means a lower temperature, means it's now colder than the surroundings, so heat has to flow into the system now, into your reaction mixture from the surroundings. And in this case, you have what we would call an endothermic reaction.